Hello everyone. Last video we saw how to check a function is analytic using Cartesian form. Now we are going to see how to check a function is analytic by expressing z in polar form. So some cases Cartesian expressing z in Cartesian form will not work out. In that case we can use polar form of expressing the complex number. So z is equal to r e power I theta. This way we can represent a complex number in polar form. So I need to check whether the function log z is analytic. So in Cartesian form, if I write z as x plus iy, I can't able to further expand and find out the real and imaginary part. So I am expressing z in terms of polar form. Z I am writing it as r e power I theta. So this is of the form log of ab. So log of AB I can write it as log A plus log B. Log of AB can be rewritten as log A plus log B. So that can be written as log R plus log e power I theta. Log e power I theta is nothing but I theta. So real part is log Z, imaginary part is theta. So now we got what is U and what is V. So now we need to find the first order partial derivatives of u with respect to r, u with respect to theta, v with respect to r and v with respect to theta. So if I differentiate u log r partially with respect to r, so that is dou u by dou r. So if you differentiate log r, you will get 1 by r. Similarly, I need to differentiate u partially with respect to theta. There is no theta available here, so partial derivative is 0. Similarly, if I differentiate v with respect to r partially, it is 0 because there is no r. And if I differentiate v with respect to theta, I'll get 1. So that is shown here. ur is dou u by dou r, which is 1 by r. Dou u by dou theta is 0. Dou v by dou r is 0. Dou v by dou theta is 1. So all the first order partial derivatives exist and they are continuous. And I need to check whether it satisfies CR equation in polar form. So what is CR equation in polar form? ur is equal to 1 by r v theta and Vr is equal to minus 1 by r u theta. So I need to check whether it satisfies. So this ur is equal to 1 by r v theta. V theta is 1. So both left hand side and right hand side is equal. Similarly, Vr is 0. So u theta is also 0. Therefore, this also gets, it is getting satisfied. But as 1 by r is there, this exists only provided r is not equal to 0. So if r is 0, then it will become undefined. So CR equation satisfied everywhere except at the point r is equal to 0. So I can conclude this function f of z is equal to log z is analytic everywhere except r is equal to 0. Except r is equal to 0 means except at z equal to 0. When r is 0, z will be 0 because z is r e per I theta. So z is 0 means except at the origin, the function is analytic everywhere. Okay. So similarly, the next example is based on the function z power n. So here also we can't able to get what is the real and imaginary part, that is u and v, if we are expressing that z in terms of Cartesian form. So expressing z in polar form will be easy for us to get the real and imaginary part, that is u and v. So we are rewriting z as r e power I theta and we can split this as r power n e power I n theta. So this e power I n theta can further expanded as cos n theta plus I sin n theta. So that we got the real part is r power n cos theta and imaginary part is r power n sin n theta. Then we need to differentiate u partially with respect to r. So we are getting n r per n minus 1, retaining cos n theta as it is. Then we need to differentiate u partially with respect to theta, that is u theta. and that is equal to n, and this r power n I need to retain as it is. If I differentiate this cos n theta, if I differentiate cos n theta, I will get minus sin n theta into n. So that is written here, minus n and sin n theta is here, retaining r power n as it is. Similarly, we need to differentiate v partially with respect to r, retaining this cos n theta term as it is. So if you differentiate r power n, you will get n r power n minus 1 with respect to r. Then if I differentiate v with respect to theta, I need to retain this r power n as it is. Then I need to differentiate this cos n theta. Derivative of cos n theta is, with respect to theta, if I differentiate, I will get this derivative. This is supposed to be sin n theta. So r power n sin n theta it is. So if I differentiate the sin n theta, I'll get cos n theta into n. So therefore next I need to check whether CR equation satisfied. U r equal to 1 by r v theta and V r equal to minus 1 by r u theta. So I can conclude that all the first order partial derivatives exist continuous and it satisfies CR equation, hence the function is analytic. So next we need to see how to find the derivative for this function. In Cartesian form it is ux plus ivx, but in polar form it is ur plus I, it is ur f dash of z. You can find out by using the result ur plus I times vr, and that should be divided by e power I theta. So this you can remember like a formula to find what is the derivative of the function f of z. So we need to substitute what is ur and vr from the previous page. There is a ur and vr is available here. We need to substitute that here. Then divided by e power I theta. So if you see the numerator, n r power n minus 1 is common. So remaining you will have cos n theta plus I sin n theta. Cos n theta plus I sin n theta can be rewritten as e power I n theta. E power I n theta. Then retain the remaining terms as it is. So you are having e power I n theta in the numerator. Denominator e power I theta is there. So bring this to the numerator and then combine the exponential terms. So if you bring this to the numerator, it will become e power minus I n theta. So if you combine it, you will get it as e power I theta into n minus 1. So already this n is there, r power n minus 1 is there. Then this e power I theta, the whole power n minus 1 is there. So altogether this r e power I theta is combined because it has same power n minus 1. So r e power I theta can be rewritten as z. So we are getting n z power n minus 1. So the derivative of the function z power n is f dash of z is n z power n minus 1. So like this we can find what is the derivative of the given function. This is in polar form. Similarly, you can try other examples and practice. Thank you.